Hi everyone, welcome to Robotics.
This is an intro to the course for robotics for both the honors course, which is COMS 4045A, and the master's course, which is COMS 7049A.
And we're just going to talk a little bit today about the logistics of the course. So we talk about this as robotics, but really you all know this better as traffic lights. So we're glad and excited that you've chosen a course on traffic lights to work on for your honors or your master's course. And really, people have this common misconception that traffic lights are all easy and it's all about just red, yellow, and green. But this is actually a very complex subject with a rich history and lots of complexity. By the end of this course, you guys will be repairing traffic lights on all street corners.
Spot the person who studied overseas.
Cool.
Okay, so first of all, Benji's joke is in fact a joke. We're not going to actually make you fix traffic lights unless it would severely help the traffic situation. The first things first, the lecturers for this course are Prof. Benjamin Rossman.
That's me.
Wait for them, Prof. Benjamin Rossman, and and Dr. Pravesh Rancher. But I think both of us prefer to just be called by our first name, so no doctors and profs here.
Benji and Pravesh.
Yeah, Benji and Pravesh. So the most important logistical thing is that the course is run through the Moodle page, which you presumably got to this video from. So you should already know how to get there. But one important thing about that is that any announcements and important things about assessments or content delivery or anything will happen on the Moodle page. So it's important to keep an eye on that. And for any info that you are not clear on about anything that's in the course, you can email Benji or myself, and our email addresses are there on the slide.
We're
For
also
this year,
doing,
we're also okay. Cool.
we're also doing an experiment this year. We're trying a Discord group. And you've got the link here on the slide as well. And that hopefully will be a more interactive, dynamic way to discuss problems in the course and bounce some ideas around. And yeah, we hope you all get engaged in that and end up discussing things, answering each other's questions, and so on. But we'll be checking it as well.
If you've never used Discord before, don't be alarmed. It's just a chat system for
Kind of
us
like a
to
fancier
live chat.
WhatsApp or something.
Yeah.
All right, then we're doing everything online, obviously, at the moment, and we'll keep you updated on that as we go along. But the way we're going to be doing this is we'll be uploading lectures every week, and the plan is to have them uploaded by Thursday at 3 o'clock, which is when the lecture should be, if it was in person. And this will give you time to actually look at the slides. So we'll have it as a slide set and a video, which we're doing today. And that gives you some time to look at them before we have our consultations.
So the consultation time is on Monday at 3, which is also the same time we'll be uploading tutorials and lab material. So you'll notice on your timetable, robotics is booked as 3 to 5 on Monday and Thursday. So what the Monday session will be is just uploads of tutorials and labs, which you then need to work through. We find that the tutorials and labs probably have the strongest correlation to performance, right? So a common thing I like to say to my students is that this course basically has a cheat code. Like, if you could come into a course and be guaranteed a pass, that'd be pretty amazing, isn't it? And you're pretty much guaranteed a pass if you do your tats and labs. So it's a hack. Fundamentally, you found the cheat code to robotics, and in fact, pretty much every other course you ever do. Do your tats and labs, and you'll be fine.
And in fact, we encourage that a little bit further because some of the tuts and labs you'll have to hand in as well for marks.
Okay, so in terms of what we'll do in the course, it's a mix of practical and theory. From the practical perspective, the most important thing we'll be doing is programming robots using the robot operating system. And a lot of the theory that we'll be doing will be sort of incorporated into these programming exercises. But I think robotics is a good case study in something that's a very good mix of theory and practical. So when you're doing the practical stuff, it's going to be very important that you're able to solve technical challenges. One of the dirty secrets of robotics is that you spend a lot of your time on not very scientific technical challenges, and part of the course is you getting good at solving those. From a programming perspective, you're free to use C++ or Python, but we'd strongly encourage Python because it's easier, and we'll be able to help you more with the Python side as well because that's what we generally use to program these robots. And you'll be doing this in groups because we find that that's just a much more pleasant way to work in programming. If you've never pair programmed before,
Time to learn.
I hope that you'll do it a lot in this course because it is an incredibly useful thing to do.
And a lot of the way that the course will work is we'll be covering concepts in theory in the lectures. And we'll be talking about the maths behind the ideas and the principles and so on. And then in the practicals, you'll be implementing this. And as Pravesh said, there's usually a bit of a gap between the theory and actually getting this to work. So you'll have a good idea of what the algorithm would look like, but then you've got to fine tune parameters and hack it a little bit to get it working. And that's something that by the end of the course, you should be quite comfortable with because it's very common in robotics. So specifically, we're going to look at a whole lot of different ideas that we'll cover in the course. Practically, you'll be using robots that have arms and robots that can move around, kind of on the ground or in the air. And we'll be looking at all sorts of different aspects here, ranging from how to figure out exactly where the robot is, where you'd like it to be, how it moves. This is the kinematics and dynamics. We'll look at how to actually control the robots, and this is called control theory. And then we'll look at a number of other things. You'll be expected to work with the sensors. This might be the cameras or telling how far the robot's moved or something like that. And we'll use all of this for a number of things. We'll try and do some planning, which is getting the robot to navigate around some environment. We'll want it to localize, which is figure out exactly where it is if it's got a map. We'll want it to do mapping, which is to build a map, but to do that, it needs to know exactly where it is. And then we'll try and do those two things together, which is called simultaneous localization and mapping. So you want to figure out where the robot is and build a map as it moves around.
Sort of like robot orienteering.
Exactly.
Cool. Okay, so what do we expect of you? Well, so I think the most important thing is that the course will require a lot of self enrichment, meaning you've got to learn things separately from being taught by myself and Benji. And one of the best ways to do that is to collaborate. And in general, you can collaborate. Just acknowledge who you collaborate with. Labs and the assignment will be done in groups. The labs will be done in groups of 2. So this is the aforementioned pair programming. And the assignment will be done in groups of 4, which means that you can almost sort of conglomerate 2 of your lab groups into an assignment group because the assignment is a fairly big task. One of the biggest advantages of this is that you'll find that the knowledge exponentially increases, so everything gets done just way faster when you've got a group that is working well.
And actually, on that point, these tasks in robotics tend to be pretty complicated. There's lots of things you need to get working. So if you think about an assignment, you might have to think about sensing information from the environment about the robot, figuring out where it needs to go, planning how to do that. There's a lot of pieces and a lot of things that you've got to work on. And so here it also makes sense to be working in groups.
Yes, and one of the major reasons that's important is because when we ask you to do things, we're often not going to tell you how to do them, right? This is honors and masters. So hopefully a lot of the courses you've done previously have required you to, do the research before doing the work. And Google is your friend, there's no doubt about that. But other people's Google is even more of your friend. So if you work in groups, it just means you have a lot that you're going to find out with very little effort.
Yeah, so try and embrace the group work. Think of it as a chance to learn that skill if you haven't worked with it much before, and hopefully that also makes it more fun.
And then I know some of you in the course are not from computer science programs. Some of you are from engineering. So there will be a lot of algorithms and programming, and none of it will be taught. So if you feel that your Python or C++ is not good enough, please take some refresher online courses or something. It's not something we intend to teach, but we will expect you to program in Python or C++. Not both, so you can focus on one. But yeah, programming is a very important part of the course.
And as Pravesh mentioned earlier, we usually recommend Python, but you can use either of these languages for a lot of this work. Cool. Then in terms of how we're going to assess you in the course, there's going to be marks coming from 4 major things. So we'll have labs, as we've been mentioning. So there'll be quite a few labs throughout the course, and we'll be asking you to submit some of these. Again, these will be done in pairs. There'll be one large assignment towards the end of the course, which will count for about 30%, and we'll give you the details on that again as we go through the course. There'll be a test, which is kind of a theory test, for 10% of the marks, and finally at the end of the course we'll have an exam.
Cool. So for all of these assessments, it's sort of a mix of the practical and theory. You will find, of course, that there is a more, like for instance, the labs are much more practical than theory, but some of the things we'll ask you to code, you'll only be able to code with an understanding of the theory. And similarly, in the test, you'll find it'll be much more theory heavy, but we could include a programming question, and then you'll get some practical in there as well.
Yeah. Then in terms of the software and hardware, now the hardware is a bit tricky because we do have a whole lot of different robots, which I think we've shown all of them on the screen here. Yeah. So these are all sitting in our physical lab, and we hope we'll have a chance to show them to you and let you play with them. But otherwise, we're going to be working in simulation. And we'll talk about some of these robots as the course progresses, and they'll be in some of the labs and tutorials. There's a few, maybe Paresh, do you want to talk about the simulation software?
Sure. So we make use of the robot operating system, and in order to run it, you need either Ubuntu 18.04, Ubuntu 20.04, or Windows 10. In theory, you can run it on any Linux and some older version of Windows, but please don't, because those aforementioned technical challenges can come and bite you. To put it in perspective, I think last year we had some students who probably spent about maybe 6 weeks of their lives trying to get this running. Whereas if you pick one of those 3 operating systems, you can just follow the instructions we'll provide and they'll just work. So, saving yourself 6 weeks is more important than running the distribution of your choice, especially since you can dual boot. The actual simulators we'll be using in ROS are the TurtleBot simulator, the TUM simulator, and the ABB Yumi simulator. And those are chosen because they model robots that we have. The big plus about how ROS works is that your code that runs on a simulator is indistinguishable from your code that runs on a real robot. What that means is if you write an algorithm that's going to properly control a simulated ABB Yumi, that's that 2-armed robot, Benji, maybe just stick your pointer on it. if you write an algorithm that'll control that robot to do something cool and awesome in simulation, you can run that exact same code to control the physical robot to do exactly the same thing. So you're not sort of being shortchanged by using simulators. It is less sort of exciting in some way to use simulators rather than the real robot. But to be honest, any roboticist will tell you they always use the simulator first anyway, because robots are quite expensive if you break them by doing something silly, and very time consuming because they operate in real time and require you to set up configurations. So simulation is a very important part of robotics, and it's not really a problem that we're going to be in simulation all this time. It does require you to have a reasonably good machine. So if your computer is not good enough to run this stuff, making use of the pair programming in groups situation is important, because then you could work with someone who does have a computer that's capable. The It's not clear whether students who are not at res will be able to use the labs, but if you are, then if you don't have a sufficiently good computer, the labs will have all of this software on it and you'll be able to use it there.
Again, this is another advantage of working in groups, that hopefully someone will have it. We'll be looking at different options to help people if you've got problems, so you'll keep us updated with how that's going. But again, the simulation is usually what happens in the course, even when we're physically present on campus. Because, for example, some of these robots, we've only got one or two of them. And again, as Pravesh mentioned, we'll be using the three main robots we'll be using is the turtle bot, which is up here at the top, which is a little robot that can drive around and see the world in front of it. The AR drone, which is this quad rotor, so it's got 4 propellers on it, and you can control it to fly around. And this ABB Yumi, which is this 2-armed, quite a lot bigger robot, which can pick things up and move things around. And so again, those will be the 3 main robots we use. We've got the simulations of all of them, and hopefully at some point you can come and see the real robots. So really, that's what we'll be looking at for this course. We hope you have a really fun time. We think this is the coolest course you can do. And yeah, so keep an eye on the Moodle page, and we'll be putting up lectures and labs soon. Cool. Thanks, guys.
Cool. Thanks, everybody. The first lecture will come out on Thursday, but keep an eye definitely on Discord.
Thanks.